Today's lesson is on writing systems of linear equations. After today, you will be able to solve real-world and mathematical problems leading to two linear equations in two variables. For our first example, we're writing a system of linear equations. A bank teller is counting $20 bills and $10 bills. There are 16 bills that total $200. Write and solve a system of equations to find the number x of $20 bills and the number y of $10 bills. First, we're going to write two equations. So for our first equation, we want the number of $20 bills plus the number of $10 bills, and that would equal the total number of bills. So for number of $20 bills, we would say x. We would then say for the number of $10 bills, we would say that's y. And then that would be equal to 16 because that's the total number of bills. So x plus y equals 16. For our second equation, we're going to have 20 times the number of $20 bills plus 10 times the number of $10 bills, and that would equal the total value. So we're going to have 20 times x plus 10 times y equals 200, or 20x plus 10y equals 200. So now we have our two equations. We're going to solve each equation for y, and then we're going to make a table of values to find the x value that gives the same y value for both equations. So when we solve the first equation for y, we would subtract x on both sides, so we would get y equals 16 minus x. When we solve the second equation for y, we would need to first subtract 20x from both sides, so we'd have 10y equals 200 minus 20x, and then we would divide by 10. That would give us y equals 20 minus 2x. Now we're going to just choose some points, and we're going to plug those into our two equations. Once we get the same value for both equations, we can stop our table. So first we're going to plug in 0. When we plug 0 in, we have 16 minus 0, and that's 16. When we plug in 1, we have 16 minus 1, and that's 15. Now if we put in 2, 16 minus 2 is 14. Now when we put in 3, 16 minus 3 is 13. And when we put in 4, 16 minus 4 would be 12. Now for our second equation, we're going to put in 0, so 2 times 0 is 0, and 20 minus 0 is 20. Then we'll put in 1, 2 times 1 is 2, and 20 minus 2 is 18. Next we will put in 2. 2 times 2 is 4, and 20 minus 4 is going to be 16. Next we'll put in 3. 2 times 3 is 6, and 20 minus 6 is 14. And then we're going to put in 4. 2 times 4 is 8, and 20 minus 8 is equal to 12. You will now notice that we get 12 for both of our equations when x is equal to 4. So our solution is going to be 4, 12. We then know that there are 4 $20 bills because x was the $20 bills, and since y stood for the $10 bills, there are 12 $10 bills. Now we have an additional example. You can either pause the video and try it on your own, or you may follow along. The length L of the rectangle is 1 more than 3 times the width W. Write and solve a system of linear equations to find the dimensions of the rectangle. So first we need to write our two equations. For our first equation, we have L equals 1 plus 3W, because it told us that L is 1 more than 3 times W. Our second equation would then be 2L plus 2W equals 42. We know that the perimeter is 42 centimeters, and we know that when we do perimeter, we do 2 times the length plus 2 times the width, and that is equal to our perimeter. These equations do not have to be in this order. You could have the perimeter equation, so the second one we did, you could have that one first, and that would be perfectly fine. Our next step is to fill out our table. So we are going to solve both of our equations for L. We want L equals. The first equation is already in that form, so we just have L equals 1 plus 3W. For our second equation, if we want to solve for L, we're going to subtract 2W from both sides, so we'd have 2L equals 42 minus 2W, and then we would divide by 2, so we could just get L. So that's how we get L equals 21 minus W. Now we're going to plug in our values for W to see what L equals. So first we'll start with 1, and 3 times 1 is 3, and 1 plus 3 is 4. Now we'll plug in 2, 3 times 2 is 6, and 1 plus 6 is 7. Then we're going to plug in 3, 3 times 3 is 9, and 1 plus 9 is 10. Next we'll plug in 4, 3 times 4 is 12, and 1 plus 12 is 13. And then we're going to plug in 5. 3 times 5 is 15, and 1 plus 15 is 16. Now we'll look at our second equation. First we'll plug in 1. 21 minus 1 is 20. Then we plug in 2. 21 minus 2 is 19. Next is 3, so 21 minus 3 is 18. Then we do 4. 21 minus 4 is 17. And last we do 5. 21 minus 5 is 16. Once you have the same number for both equations, you know that you are finished with your table. You can stop. And now what this means is that W would equal 5 centimeters and L would equal 16 centimeters. So the width is equal to 5 centimeters and the length is equal to 16 centimeters. Example number 2, we're going to be writing a system of linear equations. The sum of two numbers is 35. The second number y is equal to 4 times the first number x. Which system of linear equations represents the two numbers? We have 4 choices that we're going to be looking at. We can first write our two equations and then we'll see if they match up with one of our choices. So for our first equation, we know the first number plus the second number is equal to 35 because the sum of two numbers is 35. That would be x plus y equals 35. You can see that A, B, and C all have that equation, but D does not have that equation, so D would not be the correct answer. Now we need to look at the second equation to find out if the answer is A, B, or C. So for our second equation, we have the second number is equal to 4 times the first number. In the first equation, the first number was x, so we need to use that same thing in this equation. The second number was y, so we'll use that in this equation as well. So second number would be y equals 4 times the first number, or 4x. So we have y equals 4x. Now if you look at A, B, and C, A does not have that equation, and C does not have that equation. So our answer is B. B shows us those two equations. X plus y equals 35, and y equals 4x. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. For number 2, we have the sum of two numbers is 20. The second number is 3 times the first number. Write and solve a system of equations to find the two numbers. For our first equation, we know the sum of the two numbers is 20. So we're going to have x plus y equals 20. The first number plus the second number is equal to 20. For the second equation, we have the second number is 3 times the first number. The second number would be y, so y equals 3 times the first number, and the first number was x. So y equals 3x, or 3x equals y. It doesn't matter what order you put it in. Next, we need to solve both equations for y so that we can figure out what x and y equal. For our first equation, we would subtract x from both sides. So we'd have y equals 20 minus x. For our second equation, we already have that set to equal y, so we just have y equals 3x. We just turn it around. Now we will plug our numbers in to find out when we get the same value for both equations. So if we start with 0, 20 minus 0 is 20. Then we go to 1. 20 minus 1 is 19. And then we put in 2. 20 minus 2 is 18. When we plug in 3, 20 minus 3 is 17. When we plug in 4, 20 minus 4 is 16. And when we plug in 5, 20 minus 5 is 15. Now for our second equation, we'll do the same thing. We're going to plug in 0, and 3 times 0 is 0. When we plug in 1 for x, 3 times 1 is 3. Now if we put in 2, 3 times 2 is 6. If we use 3, 3 times 3 is 9. When we plug in 4, 3 times 4 is 12. And when we plug in 5, 3 times 5 is 15. Now you can see we have 15 for both equations. So what this represents, or what this means, is that x would equal 5 and y would equal 15. That would satisfy both of our equations because 5 plus 15 equals 20 and 3 times 5 is equal to 15. Don't forget to fill out your notes and remember to watch the video again